So continuing with 12.1, okay, how do you find the probability of an event happening? Okay, before we talked about the addition rule, adding up all the outcomes of that could happen, and there's one action, but multiple outcomes could happen is what we're looking for the topic. Topic over total, again, extremely important. Finding out what our total is, how many total ways can it happen, and think about the topic that we're looking at or the situation or event that we're looking at for that problem. We're not going to look at the multiplication rule this time. Multiplication rule, multiple actions are going to happen. Okay? Before it was one action with multiple outcomes, now this is going to be multiple actions. The key word is then. What's the chance of pulling one card, then pulling another? Two actions are happening, two actions are taking place, and you're trying to find the probability of those actions. Now, what you need to think about are the events. Are they independent, which means that the probabilities are not going to change? These events do not affect each other. Okay? Or are they dependent events, where what happened the first time around, is it going to change that next probability? So this is what you're going to have to think about moving forward. Each event, what is happening? Sometimes the probabilities will not change at all. So you need to think about independent events. Rolling a die. There's always going to be 6 sides on that die. No matter how many times you roll it, it's 1, 2, 3, 4, 5, 6. Okay? For a dependent event, the probability changes. Say if you're picking out of a group of 10 people. Okay? Well, there might be 5 boys and 5 girls. If you pull one boy out and now take him, you can't pick him again. Now there are only 4 boys and the total's now 9. That probability changed. Okay? The condition of our event is changed because of that first action happening. That's what you're going to have to think about. What's the chance of rolling an even number on a standard die, then rolling a number higher than 4? Well, we have 2 events happening here. An even number on a die, well, that's 3 out of 6. And a number higher than 4. Well, the numbers higher than 4 are 5 and 6. So that's 2 out of 6. And you're going to multiply these events together. We have event A, event B, multiply them together. And just like before, I don't want you to deal with the fractions. Let the calculator do this work for you. I have 16.667% for that event. Okay? Rolling an even number, then a number higher than 4. What's the chance of pulling a red card from a standard deck without putting it back, then pulling a club? Okay, so we have our keyword then, 2 actions, pulling one card, then you're pulling another. Now a red card, there are 26 red cards in a deck out of 52. And now think about, it says without putting it back. That's an extremely important part to this problem, because without putting it back, our total is no longer 52. Now we only have 51 cards in our deck, and we're pulling a club. There are 13 clubs. So these would be dependent events. Okay? The probability changes. It went from 52 down to 51, and now you're going to multiply across, and I have 12.745%. Okay? So the top one, rolling a die, that's independent. Always going to have 6 sides on the die, 1, 2, 3, 4, 5, 6. Dependent events, because it changed. It went from 52 to 51. So there was a change there depending on what happened in that first situation. Okay. A survey was taken on how much you enjoy bubblegum flavored toothpaste. 9 out of 11 men enjoy it, and 4 out of 7 women enjoy it. Okay? These are parameters. I'm not saying that you have a group of 11 men and 9 said that. This is, a study was done and it found that that is the proportion of men in this world, of our population of men, that said they enjoy this flavor. So that 9 out of 11 is not going to change. Okay? Again, it's not a group of 11 men. It is a parameter. That is talking about the entire population. So when you're asked a question, what's the chance of picking 3 men in a row? That in a row is another key phrase. Okay? In a row means you're doing something multiple times in a row. There's multiple actions. So what's the chance of randomly picking 3 men in a row that enjoy the toothpaste? That 9 out of 11 is not changing. Pick 3 in a row, and I'm going to multiply right across. Multiple actions, so I'm multiplying across. Okay? And that should give you, I have 54.771% if you plug that into your calculator. Okay? What's the chance of picking 2 women that enjoy it and one other man that enjoys the toothpaste. So again, it's multiple actions. You're picking 2 women, and then you're picking 1 man. There are 3 actions happening there. Now the women is 4 out of 7 and 4 out of 7. The man is 9 out of 11. So again, they're parameters. They're not changing. That 4 out of 7 staying the same for both of them. Multiply across, and I have 26.716%. Alright, so also a reminder, I'd like your answer to be in percent form with 3 decimal places. Okay, so there's a couple more examples of multiplication rule. So for complex events, some notes that you should have down. Okay, you're going to have to decide between the addition rule and multiplication rule. Okay. Keyword for the addition rule is or, for multiplication rule is then or in a row. Okay, but also think about the actions. Addition rule is 1 action. Multiplication rule is going to be more than 1 action. Multiple things are going to be happening. Okay, and the things you need to think about for addition rule, is it mutually exclusive or not? If they are not mutually exclusive, they can happen together, you have to subtract. Subtract so it's not being, events not being counted more than 1 time. For multiplication rule, you have to think, are they independent or dependent events? Is the probability changing? Now, the last thing we're going to talk about is the complement, the probability of an event not happening. Okay? Some people like to think of it of the opposite. Be careful with that. It's not exactly what the definition is, but it's the probability of an event not happening. Okay? The notation is A with a little C next to it, the event with the C, or you might just see it as A with the check mark would also be okay notation for the complement. Okay? The complement completes the probability and it makes it whole, 100%. Okay? So it's either going to happen or not going to happen. But when you add up those probabilities together, it's going to add up to 100%. So examples would be you're passing a class or failing a class. There is no middle ground there. Okay? Even if you got a D, maybe you didn't pass it by a lot, but you still passed it. You either passed or failed. Boys in class, girls in class, you're going to fall in one of those 2 categories. Okay? So you're either going to be one of the boys in the class or be one of the girls in the class. So the examples we're going to be looking at, the probability of going to a used car lot and buying a car is 23%. Questions I'm asking is, what is the complement event and what is the probability of the complement? Well, the complement event, the event we're looking at is buying a car. So if going to the lot and buying a car is what the event we're looking at, the complement of that is not buying a car. It's that simple, not buying a car. And the probability of that, remember they have to add up to 100. So you need to think, okay, 23% that I'm going to buy that car, that means there's a 77% chance of not buying that car. So there's the complement event and the probability of that complement. Okay? So that's the last little bit of 12.1 basic probability.